In modern SAP NetWeaver architectures, sudden system hangs are frequently tied to a specific operational state, work processes entering private or PRIV mode. Priv mode occurs when a process exhausts shared memory and begins consuming isolated operating system memory. Welcome to SAPTECH. Today, we are examining the mechanics of SAP memory management. The root cause of these system hangs is the complete exhaustion of the underlying memory stack by active work processes. The routing logic that dictates how this memory is consumed differs entirely depending on the specific type of work process making the request. Understanding these specific allocation sequences is the only reliable way to diagnose a priv mode hang before the operating system completely fails. In modern SAP kernels, specifically versions 7.4 and higher, the memory model has shifted. Legacy memory areas like role memory and paging have been deprecated and removed entirely. Administrators who manually hard-code outdated parameters risk starving the system of resources, directly overriding the kernel's native optimization algorithms. The modern replacement is Zero Administration Memory Management, or ZAMM. ZAMM is a framework designed to automate the allocation of memory resources. Instead of requiring individual hard-coded values for every buffer, ZAMM dynamically calculates all memory limits from a single master parameter. This overarching control for the entire instance is phys mem size. It tells the SAP instance exactly how much physical RAM it can use. By tuning phys mem size at the instance level, the kernel is freed to automatically handle granular memory sizing, preventing the misconfigurations that lead to system crashes. To see how this routing logic operates in practice, we have to analyze what happens in the architecture when an interactive user executes a standard transaction. The dispatcher immediately assigns a dialog work process to handle this interactive request. The user context, which includes the user's initial login information and their active internal and external sessions, requires an immediate memory allocation to function. For dialog processes, SAP always allocates memory from extended memory, or EM, first. Extended memory is specifically defined as shared memory, meaning it is a central pool accessible by multiple work processes. The operational benefit of this shared memory is that it allows for extremely fast user context switching. If a user pauses their activity, the work process can safely detach, leaving the user context parked securely in extended memory. This detachment allows the exact same work process to serve a completely different user without losing any data from the previous session. However, the total quota for a single dialog user within this shared pool is strictly restricted by the parameter ZTTA/role-extension. This EM-first routing algorithm maximizes the multiplexing efficiency of the dispatcher, guaranteeing that interactive response times remain low across the system. Consider a scenario where a dialog user decides to pull a massive data table in the foreground, pushing their memory consumption to the absolute limit. As the user pulls more data, their context expands until it exceeds the EM quota set by the ZTTA/role-extension parameter. At this tipping point, the failover mechanism engages. The dialog work process is forced to spill over into the OS-level heap memory.
Heap memory is strictly private memory. It is bound directly to the underlying operating system resources rather than the shared SAP pool. The exact moment a work process allocates any heap memory, it officially enters priv mode. The immediate consequence of priv mode is that the work process is now exclusively locked to that specific user context until the entire transaction ends. Because it is locked in this private state, it can no longer be detached or multiplexed by the dispatcher to help other users. A cascading failure occurs when too many processes enter this locked state simultaneously, starving the dispatcher of available workers. As more processes lock into heap memory, the operating system's physical memory limit, governed by the parameter abap/heap area total, becomes rapidly exhausted. While priv mode acts as a protective failover for a single heavy transaction, it ultimately creates a critical vulnerability that leads directly to hard system hangs if left uncontrolled. We must contrast this with the other side of the system, non-dialog processes, which include background, update, and spool tasks. These specific processes follow an entirely inverted memory allocation sequence compared to interactive users. Background jobs, by their very nature, do not require fast user context switching. Instead, these jobs typically process massive, resource-heavy datasets that take hours to complete.
Because of these two factors, SAP allocates heap memory first for non-dialog processes. This initial private allocation for background jobs is governed by the parameter abop/heap area/non-dia. SAP engineered this inverted routing logic for a highly specific strategic reason. It physically protects the shared extended memory pool from being drained by massive background data extractions. This architectural segregation guarantees that interactive users do not experience severe latency spikes while heavy background batch jobs execute simultaneously. This is a recreation of the SAP ST02 memory tune screen. You can monitor this architecture in real time using this transaction. The primary goal in ST02 is ensuring your extended memory buffer hit ratios remain optimal. You must verify that dialog processes are not constantly dipping into heap memory during normal daily operations. If you are diagnosing an active incident, you may spot work processes flagged in priv mode within transaction SM50. This is a view of the SAP SM04 screen, focusing on the memory column. Use this transaction to track the exact memory consumption for each individual user session. Combining ST02's macro architectural view with SM04's micro user view allows an administrator to pinpoint the exact session bypassing its EM quota and threatening the operating system. The core rule of modern SAP memory management under the ZAMM model is automation over manual restriction. Tune phys_mem size at the instance level rather than manually hard-coding outdated legacy limits. Trusting the ZAMM algorithmic routing ensures dialog and non-dialog processes respect their optimal EM and heap boundaries naturally. Check the detailed information and parameters provided in the video description below. If you found this architectural breakdown valuable for your daily administration, subscribe to the SAP Tech channel.